For a turbine engine, the term self-sustaining speed relates to the speed at which the engine will run without any external assistance.
In a single-spool gas turbine engine, the compressor RPM is the same as turbine RPM. The fan of a turbofan engine is driven by the low-pressure turbine.
For a fan jet engine, the bypass ratio is the cold air mass flow divided by the hot air mass flow. With regard to a twin-spool turbofan, an abortive start, hung start, will result in N2 speed stabilizing at a lower than normal RPM and a subsequent increase in EGT.
In a turbojet, the purpose of the turbine is to drive the compressor by using part of the energy from the exhaust gases.
If an abortive start hung start occurs when starting a gas turbine engine, the correct action is to shut down the engine.
The bypass ratio in a turbine engine is the ratio of cold air mass flow to the hot air mass flow. An abortive hung start is the term used to describe an attempt to start in which the engine lights up but fails to accelerate sufficiently.
After a successful start of a high bypass turbofan engine, the air starter is disengaged by the coupling between engine N2 spool and starter by the use of centrifugal forces. The most important all-system instrument indication during gas turbine engine start is oil pressure.
The purpose of gas turbine engine trending is to enhance maintenance planning and detect anomalies.
The most unfavorable conditions for adequate inlet air flow of a turbofan engine are maximum takeoff thrust, zero forward speed, and strong crosswind condition.
Which of the following parameters remains constant in a divergent subsonic gas turbine engine intake? Total temperature. In a subsonic convergent duct, the velocity increases, pressure decreases, and temperature decreases.
The internal geometry of a turbofan intake for a subsonic commercial airplane is divergent in order to reduce airflow velocity and increase static pressure in front of the fan.
For a subsonic airflow in a divergent duct, the pressure increases, velocity decreases, and temperature increases. For a subsonic airflow, air passing through a divergent duct decreases in velocity and increases in pressure.
In a gas turbine engine, the maximum gas temperature is attained within the combustion chamber.
During the ram recovery process in a gas turbine engine subsonic intake, the flow velocity decreases. One of the functions of a gas turbine engine subsonic intake is to decrease airflow velocity.
Vibration sensors are used in a gas turbine engine to indicate imbalance of one or both of the spools. Jet engine total efficiency indicates the efficiency at which chemical power in the fuel is transformed into propulsive power, T times V.
EPR can be defined as the ratio of the total turbine outlet pressure to the total compressor inlet pressure.
A flat-rated turbofan will be temperature limited if outside air temperature is higher than flat-rated temperature.
The characteristics of an axial compressor are a low pressure ratio by stage and the possibility of compressing a large mass airflow. The characteristics of a centrifugal compressor are a high pressure ratio by stage, a large diameter.
In a free turbine engine, there is no mechanical connection between the compressor and the power output shaft.
In a free turbine engine, the energy delivered by the free turbine stages is dependent on the rotational speed of the gas generator. The heat for the anti-icing system of a turbofan engine intake is provided by bleed air from the HP compressor.
Ice formation on turbofan engine intakes is usually prevented by using compressor bleed air. Using compressor bleed air to power systems decreases aircraft performance.
Compressor stall in a gas turbine engine can be caused by an axial airflow velocity that is low relative to the rotor speed.
The compressor pressure ratio of an axial flow compressor is primarily determined by the number of stages. On landing and prior to shutdown, a gas turbine engine should be run at ground idle for a short period. This allows the core temperature to diminish.
A gas turbine engine turbine section may employ active clearance control to provide enhanced clearances between the blade tips and the casing.
In which part of a gas turbine engine are high temperature requirements most critical for the materials used? The combustion chamber and front part of the HP turbine. The primary function of the diffuser, located between the compressor and the combustion chamber of a gas turbine engine, is to decrease the flow velocity.
The primary function of the diffuser, located between the compressor and the combustion chamber of a gas turbine engine, is to decrease the flow velocity.
The turbine in a gas turbine engine generates shaft power using expansion of hot gas followed by conversion of kinetic energy velocity into mechanical work.
If air is tapped from a gas turbine HP compressor engine N to control the effect on the engine pressure ratio EPR and the exhaust gas temperature EGT is that EPR decreases and EGT increases. If air is tapped from a gas turbine HP compressor, the effect on the engine pressure ratio EPR and the exhaust gas temperature EGT is that EPR decreases and EGT increases.
The disadvantages of axial flow compressors compared to centrifugal flow compressors are more expensive to manufacture and greater vulnerability to foreign object damage. A modern auxiliary power unit APU is designed to provide power for ground starting of an engine. It also supplies both in the air subject to certification limitations and on the ground. Air conditioning and electrical services.
A hung start is the failure of an engine to accelerate to its normal idle speed. It may be caused by an attempt to ignite the fuel before the engine has been accelerated sufficiently by the starter.
In a gas turbine engine lubrication system fitted with an oil-to-fuel heat exchanger, the oil is cooled through thermal exchange with the fuel. The primary input signals for a hydromechanical gas turbine engine fuel control system include N2, compressor discharge pressure, compressor inlet temperature, fuel shutoff, thrust lever angle.
Static gas temperature decrease when flowing at a subsonic speed through a jet engine exhaust nozzle because the exhaust nozzle is convergent.
The operating pressure of a booster pump in the fuel supply system of a gas turbine aircraft is within the following range 20 to 100 psi. In the event of an engine fire, the fuel supply is isolated from the engine by pilot action.
Labyrinth seals in the lubrication system of a gas turbine engine are designed to provide a seal that is not completely tight, allowing some movement between rotating and static parts.
If a gas turbine engine fuel oil heat exchanger is located downstream of the HP fuel pump, internal leakage of the heat exchanger will cause the oil level to rise. If the main oil filter of a gas turbine engine becomes clogged, oil to the main bearings is still assured, because the oil filter bypass valve opens.
The accessory units driven by the accessory gearbox of a turbojet engine are the AC generator through its constant speed drive CSD, oil pumps, hydraulic pumps, high pressure fuel pumps.
Engine auxiliary gearboxes provide the drives for a wide variety of services and may even provide for the support of the engine in the airframe. An aircraft flying in conditions of continuous heavy rain and high ambient temperatures may require the precautionary use of engine igniters.
In an ignition system during a normal start of a gas turbine engine, igniter activation should commence prior to fuel entering the combustion chamber.
To achieve reverse thrust on a turbine engine with a high bypass ratio, generally, the fan flow is deflected. The function of a vibrator in some gas turbine ignition systems is to provide DC current to the transformer to facilitate the generation of a higher voltage to the ignition.
On most high bypass ratio fan engine, reverse thrust is achieved by reversing only the direction of the fan airflow.
The thrust reversers of jet engines may use clamshell doors in order to change the direction of the exhaust gas stream. The following problems may occur when starting a twin-spool turbofan engine. No N1 rotation, although in the second may accelerate normally.
Most high-bypass and mixed turbofan engines are equipped with a cold exhaust reverser TAN reverser only in order to save costs and mass at the expense of a reduction in available reverse thrust.
If a twin-spool gas turbine engine is controlled by a conventional N2 control system, rupture of the LP shaft may result in overspeed of the LP turbine.
Increasing the power setting of a gas turbine engine with a constant speed propeller and free power turbine causes both HP spool speed and EGT to increase. In the axial flow compressor of a turbojet engine, the flow duct is tapered. Its shape is calculated so as to maintain a constant axial speed in cruising flight.
For a fan jet engine, the bypass ratio is the external airflow mass divided by the internal airflow mass. The purpose of the blow-in doors at the air inlets is to provide the engine with additional air at high power settings and low air speeds.
The primary performance indicator cockpit instrument for the thrust of a turbofan engine is either EPR or N1.
The selection of bleed air 2 on will cause a decrease in power and an increase in exhaust temperature. Bleeding air from the HP compressor of a turbofan whilst maintaining thrust increases. EGT and fuel flow.
Some gas turbine engines have multiple stages in the HP and LP turbines because one stage does not generate sufficient shaft power.
Bypass turbine engines are mainly used in commercial aviation because at high subsonic air speeds, they have a better propulsive efficiency than propeller or straight jet engines.
The kind of compressor normally used as a supercharger is a radial compressor. The bypass ratio of an engine is the ratio of cold stream air to that flowing through the hot core of the engine.
A stage in an axial compressor consists of a rotor disc followed by a ring of stator blades. An engine pressure ratio EPR can be defined as the ratio of jet pipe total pressure to compressor inlet total pressure.
An axial compressor, when operating below its design speed, has a tendency to stall in the front stages.
The primary function of the diffuser, located between the compressor and the combustion chamber of a gas turbine engine, is to decrease the flow velocity.
The purpose of variable bypass valves in a high bypass turbofan engine between the LP compressor and the HP compressor HPC is to prevent fan stall and LP compressor stall during engine start and low rotor speeds. The fan of a turbofan engine is driven by the LP turbine.
Engine auxiliary gearboxes provide the drives for a wide variety of services and may even provide for the support of the engine in the airframe.
What is the correct sequence during the start of a turbine engine on the ground? Starter, rotation, ignition, fuel.
If the main oil filter of a gas turbine engine becomes clogged, oil to the main bearings is still assured, because the oil filter bypass valve opens.
What is the correct sequence during the in-flight windmilling start of a turbine engine? Rotation, ignition, fuel.
The bypass air in a turbofan engine has the effect of a lower specific fuel consumption by causing an overall decrease in average exhaust gas flow velocity and a higher mass flow velocity and a higher mass flow. The oil system of a gas turbine engine may be fitted with magnetic plugs or chip detectors that provide warning of impending failure without having to remove the filters for inspection.
Concerning the starting procedure of a gas turbine engine, the selected igniters are activated after fuel is delivered to the fuel nozzles.
For a turbine engine, the self-sustaining speed relates to the minimum RPM at which the engine will continue to operate without any starter motor assistance.
A turbofan cold air unit will not affect the charge air pressure.